If I told you to picture a human brain literally rewiring its own physical architecture, like adding structural density and actively fighting off Alzheimer's disease, you'd probably picture someone, I don't know, trying to solve complex quantum physics equations.
Right, or like a grandmaster staring down a chessboard.
Exactly. You definitely wouldn't picture someone sitting quietly on a park bench, wearing a bucket hat, just staring at a pigeon through binoculars.
No, definitely not.
But according to the latest neuroscience, maybe you should.
Yeah, it completely shatters our conventional understanding of what a mental workout even is. I mean, we've been conditioned to believe that cognitive preservation requires this grueling, frustrating mental exertion.
Like deadlifting weights, but for your frontal lobe.
Exactly. But this research completely redefines observation. It proves that sustained, detailed attention to the natural world, it actually leaves a permanent physical footprint on our neural circuitry.
It's mind-blowing. So today, our grounding source for this deep dive is a piece from Psychology Today by Dr. Austin Perlmutter, and it's titled, What Birdwatching Does for Your Brain.
It's a great piece.
Yeah, we're going to examine the evidence showing how this incredibly quiet, seemingly passive, everyday hobby literally changes the physical structure of your mind. So if you're looking for the ultimate brain hack to stay sharp, you're going to want to hear this.
Absolutely. We have a ton of research to cover today.
We really do, including some major findings from the Rotman Research Institute. But before we get to the neuroplasticity and the brain scanners, we really need to establish the sheer scale of the population we are actually talking about here.
Yeah, the numbers are huge.
Okay, let's unpack this, because the data completely upends the stereotype of birdwatching as just this tiny niche activity for retired folks.
It really does reframe the entire conversation.
Yeah.
I mean, according to the U.S. Fish and Wildlife Service, almost 100 million people in the United States report being birdwatchers.
Wait, 100 million?
Yeah, nearly a third of the American population is actively engaging in this hobby on some level. It's just a massive demographic.
That is wild. And it spans the globe, too. Like in the UK, they host this annual Big Garden Birdwatch, and it pulls in hundreds of thousands of active participants every single year.
Right. So you have millions of people dedicating massive amounts of cognitive resources to observing and, identifying subtle variations in wildlife.
And the global pandemic acted as a massive catalyst for all this, didn't it?
Oh, for sure. When the world locked down, I mean, people couldn't travel, they couldn't go to theaters.
Right.
So they turned their attention to the only dynamic moving environment they had left, which was the natural world right outside their window.
Just staring out the glass.
Exactly. And that forced shift in attention is really what primed the scientific community to take a closer look.
Because when a third of the country suddenly starts engaging in this specific type of intense visual and auditory categorization, neurologists pay attention.
They have to. The scientific inquiry just pivoted from, isn't it nice that people are connecting with nature, to a very pointed biological question.
Right, like does this intense visual focus actually alter the hardware?
Exactly. Does identifying a specific species of bird out of hundreds of possibilities physically change the brain?
And that specific question is what led researchers at the Rotman Research Institute in Toronto to set up an incredibly rigorous study, which was eventually published in the Journal of Neuroscience.
A highly respected journal.
Yeah. And they recruited 58 adults across a wide age range. So we're thankfully not just looking at a convenient sample of 20-year-old undergrads.
Right, which happens way too often in these studies.
So true. And they split them evenly. Half the group were expert bird identifiers who had spent years honing the skill, and the other half were complete novices.
And they essentially took these outdoorsy, field guide carrying experts, pulled them out of the forest, and put them through advanced neuroimaging.
I love this visual. It's like putting a professional athlete in an MRI to study their muscles, but for visual observation.
It really is. And what's fascinating here is the dual imaging methodology the researchers utilized to capture the full scope of the brain's adaptation.
Okay, dual imaging, what does that mean?
Well, they didn't just take one static snapshot. They combined diffusion-weighted MRI with functional MRI, or fMRI.
Oh, so they were looking at the architecture and the electricity simultaneously.
Excellent.
Like the diffusion MRI maps the physical integrity of the white matter tracks, right? The structural cables connecting different brain regions.
Right, the permanent infrastructure.
Okay.
And then the fMRI watches the oxygen and blood flow to see the software running in real time while they perform a task.
Okay, so you're capturing the structure and the metabolic demand all at once.
Exactly. So while the participants were inside the fMRI scanner, The researchers had them actively identifying different birds. This allowed them to pinpoint exactly which networks were firing up to process that specific type of complex visual data, and then they could cross-reference those active networks with the structural maps from the diffusion scans.
And the results from those scans are where Dr. Perlmutter's article really shifts from an interesting behavioral study into profound human biology.
That's where it gets real.
Yeah, because when they compared the expert birders to the novices, the experts displayed a distinct physical difference in their brain structure. The text specifically notes their brains were more compact in the frontoparietal and posterior cortical regions.
Yeah, and those two regions represent a highly specialized network.
Okay, break that down for us.
So the frontoparietal network is essentially the brain's executive control center for sustained attention. And the posterior cortical region handles high-level visual and spatial processing.
Got it. So when you were trying to spot a tiny, fast-moving target hidden within the complex geometry of a tree canopy, you were basically redlining those specific neural pathways.
You're pushing them to the limit, yes.
Oh, wait, I want to push back on the terminology for a second. The word compact.
Uh-oh.
Yeah, because it sounds inherently negative when we're talking about human biology.
Right.
I mean, if my brain is becoming more compact, my immediate assumption is that it's shrinking, right?
It does look.
Brain health with volume, not density.
I know. It is a totally counterintuitive term if you aren't looking at it through the lens of neuroplasticity and metabolic efficiency.
Okay, so it doesn't mean shrinking.
No, in this context, compact does not mean you are losing functional brain mass. You have to remember your brain consumes roughly 20% of your body's total energy.
It's an absolute metabolic furnace.
Yes. So when you are a novice at a task, your brain fires incredibly inefficiently. It sends signals down these broad, messy, scattered pathways, just wasting a ton of energy trying to process the stimulus.
Oh, I see. It's throwing everything at the wall to see what sticks because it doesn't have a specialized system yet.
Exactly the opposite of an optimized system. Think of it like pruning a bonsai tree.
Okay, pruning.
By deliberately snipping away the hundreds of weak, sprawling, useless twigs, the tree redirects all its metabolic energy into making the main branches incredibly thick, strong, and resilient.
Wow. And the brain is doing the exact same thing with neural pathways.
Yes. As these birders spend hundreds of hours intensely focusing on subtle visual cues, the brain prunes away the unnecessary synaptic connections and heavily myelinates the crucial ones.
Okay, so a more compact brain structure in those attention regions means the tissue has simply become a highly specialized, hyper-efficient processing machine.
You've eliminated the noise.
That makes so much sense, like going from a messy closet to a highly organized filing cabinet.
That's a perfect analogy. And the study actually proved a direct correlation there. The more compact the structural wiring in those frontoparietal regions, the higher the individual's accuracy was in identifying the birds.
So the structural density dictated the functional performance. That is amazing.
It is. But the researchers discovered an even more profound layer to this neuroplasticity.
Ooh.
Yeah. When the expert bird watchers were asked to identify birds they were less familiar with, those exact same optimized, compact brain regions lit up on the fMRI.
Wait, really, that is the crucial detail.
Right.
Because it means they haven't just memorized a massive database of flashcards. They haven't just memorized what a robin looks like.
No, they haven't.
They have fundamentally upgraded the underlying algorithm their brain uses to process visual information. They've literally built a better lens.
The tool itself has been sharpened.
Yeah.
And the implications of possessing a physically upgraded attention network, they extend far beyond a weekend hobby.
Which is where this gets into the anti-aging stuff.
Exactly. This structural rewiring acts as a powerful cognitive defense mechanism against the aging process. The cognitive reserve built through this kind of intense observation provides a literal buffer against neurological decline.
And Dr. Perlmutter makes that connection very explicit in the article. He shifts the focus from the mechanics of observation to the broader landscape of anti-aging.
Right.
He actually points to a fascinating October 2025 study published in Nature Communications titled Creative Experiences and Brain Clocks.
Oh, that Nature Communication study is incredible. They utilize machine learning to analyze structural brain scans and estimate a person's brain age compared to their actual chronological age.
And what did they find?
They definitively proved that people who consistently engage in creative, cognitively demanding experiences possess youthful-looking brains.
Wow, youthful hardware.
Exactly. The structural integrity of their white and gray matter looked years younger than their peers, and that youthfulness was directly proportional to their level of expertise in their chosen pursuit.
Which perfectly maps onto the Rotman birdwatching study. The deeper the expertise, the more pronounced the physical neuroplastic benefit. But the statistics get even more intense from here. Dr. Perlmutter cites another major study from the journal Neurology regarding what they call lifelong learning, or cognitively enriching
Right,
activities.
the lifelong learning data.
Yeah, and this is huge. Individuals who maintained high engagement in these enriching activities demonstrated a 38% lower chance of developing Alzheimer's disease.
A 38% risk reduction
Mhm.
for a neurodegenerative disease that is notoriously difficult to combat. That is a staggering figure.
It really is.
Furthermore, the study measured the temporal impact. For the individuals who were highly engaged in cognitive enrichment but eventually developed Alzheimer's anyway, their mental enrichment provided an average 5-year delay in the onset of the clinical symptoms.
5 extra years. But okay, here's where it gets really interesting.
Okay,
Because looking at those numbers, a 38% reduction and a half-decade delay in Alzheimer's symptoms, I kind of have to play devil's advocate here.
go for it.
Is it actually the cognitive demands of the bird watching doing the heavy lifting? Or are we just looking at a demographic correlation?
The correlation versus causation question.
Yeah, because think about it. Bird watchers tend to be slightly older, perhaps wealthier, retired people who have the free time to just wander through parks.
Fair point.
They might have lower baseline stress, better access to health care, better diets. Do these studies actually isolate the hobby from the socioeconomic factors?
It is the absolute most important question to ask when looking at epidemiological data.
Right.
But rigorous studies, like the ones in neurology, they use multivariate analysis specifically to control for socioeconomic status, baseline health, and education levels.
Okay, so they account for all that.
Yes, even when you strip away the benefits of wealth or better health care, the variable of cognitively enriching activity remains a massive, independent protector.
Wow.
The mechanism here is called cognitive reserve. As Alzheimer's physically degrades brain tissue, a brain with dense, optimized, compact pathways essentially has a redundant power grid.
Oh, I like that, a redundant power grid.
It can bypass the physical damage and maintain functional cognition for years longer than a brain with weak, inefficient pathways.
So the disease might still be physically attacking the hardware, but the network is so robust that it just routes around the damage.
Exactly.
It gives you 5 extra years of cognitive clarity, of recognizing your family, of maintaining your independence. That is just beautiful.
It really is.
But that raises another question for me. Does it have to be bird watching? I mean, could I get that exact same robust cognitive reserve by doing a daily crossword puzzle or finally learning how to play the guitar?
Well, any sustained, complex, lifelong learning activity that forces the brain to adapt will contribute to your cognitive reserve.
Okay, so guitar works.
Sure, the brain demands novelty to trigger neuroplasticity. However, the reason Dr. Perlmutter centers this discussion on birdwatching is that it occupies a highly unique intersection of multiple different neurobiological benefits.
It's not just one thing.
Right. It isn't an isolated, static cognitive task, like sitting alone in a room doing a Sudoku puzzle.
It's a compound effect. Like, this deep dive reveals all these secondary compounding benefits mentioned in the text that elevate this from a simple visual puzzle into a holistic neurological powerhouse.
Absolutely.
Let's break those secondary elements down, starting with the social interaction. Joining a birding group or sharing findings with a community, I mean, that taps into one of the strongest pillars of brain health, right?
Definitely. We know isolation accelerates cognitive decline, while social engagement triggers neurochemical rewards that protect the brain.
Yeah.
Social interaction fundamentally lowers systemic inflammation, which is a known driver of neurodegeneration.
Wow. And then you have the inherent physical requirement. Like, you aren't spotting a wide variety of species from your living room couch.
No, you are navigating uneven terrain, you're walking miles through parks and carrying heavy optics.
And that physical movement increases cardiovascular output, which directly spikes the production of brain-derived neurotrophic factor, or BDNF.
Yes, BDNF is essentially fertilizer for the brain. It promotes the survival of existing neurons and encourages the growth of new synapses.
So you have the cognitive puzzle of identification, the social buffering of a community, the physical cardiovascular boost increasing BDNF.
Right.
And all of this is happening within a natural environment, which the article strongly emphasizes. Simply being in nature, engaging in a digital detox, it provides a profound reset for the brain's attention networks.
Oh, it's vital. We are constantly bombarded by the rapid-fire stimuli of digital screens,
It
right?
really is.
And that keeps our sympathetic nervous system in a perpetual state of low-grade alert. Stepping into a natural environment forces a digital detox, shifting the brain into a state of soft fascination.
Soft fascination, I love that term.
And this transition is critical for stress reduction. Chronic stress is not merely an emotional or psychological burden, it is a physical neurotoxin.
The cortisol just floods the system.
It does. Chronically high cortisol levels literally cause the dendrites, the branching receptive structures of your neurons, to shrink and retract, especially in the hippocampus and the prefrontal cortex. Chronic stress actively reverses the compacting and optimizing we just talked about.
So it's undoing the good work.
Exactly. But by immersing yourself in a natural environment and focusing on a quiet task, you lower cortisol levels, halting that dendritic retraction and allowing the neural pathways to heal.
So what does this all mean? It functions like a biological Swiss Army knife for cognitive preservation, hitting visual acuity, executive function, cardiovascular health, and stress reduction all at once.
A perfect summary.
But we absolutely must include the medical caveat Dr. Perlmutter lays out, because this is an optimization tool, not a magic eraser for terrible lifestyle choices.
Oh, 100%.
You can't just subsist on a diet of processed sugar, sleep 4 hours a night, stare at a hawk for 10 minutes, and expect your brain to rewire itself into a fortress against dementia.
If we connect this to the bigger picture, neuroplasticity is a very resource-intensive process. The brain cannot build that compact, highly efficient architecture if it lacks the basic building blocks.
It needs fuel.
Right. Dr. Perlmutter is super clear on this. This hobby does not replace the fundamental biological requirements of a nutrient-dense diet, restorative sleep, and baseline physical health.
Of course not.
Birdwatching sits at the apex of those foundational habits, leveraging a healthy system into a highly optimized one.
It's the ultimate form of active maintenance.
Exactly.
Man, we started this deep dive looking at what appeared to be just the most passive, tranquil way to spend a Sunday afternoon.
And it turned into neuroscience.
Right. Tracking the data from nearly 100 million participants through the diffusion MRI scanners in Toronto all the way to a 38% reduction in Alzheimer's risk. It just reveals a wildly different reality.
It really does.
We've seen how the intense granular focus required to differentiate wildlife physically prunes and compacts the frontoparietal networks of the brain, literally upgrading our entire algorithm for attention. And we've seen how building that cognitive reserve acts as a redundant power grid, potentially buying us half a decade of functional clarity against cognitive decline. Taking up a complex observational hobby isn't just killing time. It is a structural renovation of your mind.
It highlights the profound reality that our daily allocation of attention directly dictates the physical structure of our biology.
So true.
And as we conclude our analysis of the research today, it leaves us with a rather provocative question to consider.
Okay, lay it on us.
Well, we now have concrete proof that actively observing the complex, subtle, three-dimensional details of the natural world forces our brain's attention centers to become structurally more compact, specialized, and efficient.
Right.
So we have to ask, if active natural observation builds a highly optimized brain architecture, how might our modern default habit of passively staring at glowing two-dimensional screens for hours on end be altering our brain's physical structure in the exact opposite direction?
Wow, that is a deeply unsettling thought to keep in mind the next time you catch yourself mindlessly scrolling through a feed.
It really makes you think.
Every single time you choose where to place your attention, you are providing the architectural blueprints for how your brain will build itself tomorrow. Thank you for joining us on this deep dive.
It's been great.
We hope you walk away with a completely new framework for understanding observation and cognitive reserve. Take some time this week to step outside, leave the phone behind, look up into the canopy, and give your brain the exact kind of high-level workout it evolved to perform. See you next time.